Welcome to the OMG Genomics podcast. We are your hosts, Maria Nadestad and
Robert Abukhalil. And today we're going to talk about scientific software that's built in academia and what happens to it when you leave your lab and you go to industry or you move on to a different lab.
Yeah, and we have several personal examples of this. And we can also talk about some examples of tools around our field of genomics that are maintained really well. For tools that are maintained poorly, we'll only talk about our own examples, so you're all off the hook, don't worry.
Great. So let's start with some positive examples.
Yeah, I have a couple I wrote down, just like off the top of my head, things I use all the time. Bed tools, samtools, sniffles, and bowtie. These are all really well maintained, and one thing I see in common with all of them is that the people who created them, usually I think in their PhDs or in their postdocs, that person ended up becoming a professor later, and now their lab, or in some cases like samtools, everybody just uses it, so I think it's a much larger user group that maintains it too. But usually like the person becomes a professor, and that's how the software like continues to get that investment that maintains it, has future versions of it. Like you start to see 2.0 or the Python version. I think you had an example for that actually with bed tools, right?
I think it was Jbrows. So Jbrows is a genome browser. They've been there for like 15 years. And so, they've released multiple versions and different packages for Python and R. And so they, there's a whole lab behind it that's maintaining it. And, one thing I found interesting is that for Jbrows, over 15 years, they were able to publish 8 papers on the same tool.
Wow.
Just major upgrades and new tools, which I didn't realize before looking this up, because I kind of assumed, you write a paper about a software that's one and done.
Yeah.
And the rest is kind of up to you to maintain it.
Mm-hmm.
But it seems like there are tools, even like bowtie, minimap, and bed tools and samtools, they all have multiple papers. So they're still able to get that needed recognition through papers, even though, it shouldn't be that way. But,
It shouldn't be that way? What do you mean?
Like, you shouldn't need to publish papers to demonstrate that your worth as an academic.
Yeah, to like academically get credit.
Right.
That counts towards the professor's promotion, towards the graduate students and postdocs and so on who work on maintaining the software. Like, I wonder how that fits into their careers. Like, do they have to make a new version they can write a paper on? And is that the flagship of that student's PhD? Or is it just like a tax everyone in the group kind of pays for being part of that lab?
Right.
Like, I kind of wonder.
And I'm sure like it helps grants as well, just to say that you have another paper. Even though personally I think just a blog post would be fine. This is
but that counts for nothing for
apparently
all those poor people out there who stayed in academia. Which kind of brings us to another thing. Like for us, we moved on to industry after our PhDs, both of us. So for us, there's virtually no incentive career-wise to actually maintaining our software. I think in my case, I only do it because I would feel really bad to shut it down because people are depending on it and still using it, and I don't want to disappoint them. It's hard enough to be a scientist, and like finding the right bioinformatics tools is difficult enough without half of them being like shut down.
Yeah. So do you get people reaching out to you?
Oh yeah, lots.
I guess in a way that's a positive. Like, how long ago was that software?
8 years. Yeah, so this is for 3 of my software packages. They're all about 8 years old, roughly, now, and it's Assemblytics, SplitThreader, and Ribbon. And I think for Ribbon, that's the one we've put the most effort into maintaining, and I say we because you actually had an idea for adding BioWAS and like WebAssembly powered samtools to Ribbon. And so that one we ended up publishing in 2020. So that's only 4 years ago, for those of you who are way later in the future listening to this. So like that one kind of got a second life, and that was actually when we published Ribbon, because previously it was just on the bioarchive. It had kind of not gotten, like I had finished the paper, but I hadn't seen it through publication in a peer-reviewed journal before leaving my PhD, so it kind of got left behind a little. And that one we kind of gave it that, boost of actually, doing something that would make it feel finished.
Yeah.
And add you as a co-author to the paper. That was also a nice benefit.
Our first paper together. Yes.
That's right.
Yes.
I mean, it feels like we should be doing a lot of things together, but we don't have a lot of things that actually have both of our names on them.
Yeah.
Now there's this podcast, but
That's true.
Yeah.
So on my end, the software from academia that most people reach out to me about is Ginkgo. It's a single cell copy number analysis tool.
Right.
And it has a lot of issues, namely that, I wrote it 10 years ago. I'm a much better engineer now. I would have done things so much differently. But also the field has just moved on so quickly that some things are outdated. Because the field moves quickly, you're able to sequence a lot more cells more cheaply. That overwhelms the server.
Yes.
And it's not like a server that I own or maintain.
Have SSH
I
access
can't even
to anymore.
Yeah. So that presents some challenges too. And I also feel bad. I don't want. Clearly, people are still using it, even though it's quite old. But
Yeah, I think that's a really interesting example because people are still using it, but they're using it differently than they used to. So, you had not anticipated the numbers of cells that people would insert into your single cell analysis tool. So not only does it overwhelm the server, but it could also just crash the code.
Right, because at the time
it could.
Yeah, at the time it was so expensive that if you had 100 cells, you were really spending a lot of money doing sequencing.
Right.
So now it's just, you can have tens of thousands easily, and that just was not planned for.
Yeah, and you do things like make a plot for every cell.
Yeah.
Do you have a file for every cell somewhere in the...
Multiple files for every cell.
Oh, no.
Which, and that's another thing that I hadn't even thought of, is like a lot of the visualizations don't make sense anymore. Like people aren't going to want to look at just every cell at a time. They're going to want aggregation features and so on.
Yeah.
But like how do I justify spending my limited free time on this?
Yeah.
That's kind of hard to do. And I think that one thing I wanted to talk about is that there are, like, the way we do it in industry is if you leave the company, you hand off your software to someone else, or assuming you have a team already, you just kind of knowledge transfer. But I haven't seen that too often in academia, where people leave and they hand it off. And I think that's primarily because most of the people in academia are grad students and postdocs. Whereas what you would want is some sort of research software engineer staff who takes it on and maintains it. But then how do you justify their salary?
Right. How do you make
they're not
this
producing
fit
papers?
in? Yeah. Like, how do you fit this into people's careers?
Yeah.
Because, like, we do want scientists to keep growing. So I don't, for instance, want the person who created the software to have the obligation to stay on and keep maintaining it themselves forever. But of course they're going to leave, they're going to build the next thing. They don't get any academic credit for staying and maintaining the original. They have to write the next paper and the next and the next. And I think for me, like, having 3 tools come out of my PhD, which I don't know how I had the time, I needed them all for my own research. It was basically just like a necessity that, is the mother of invention, they say. So, like, I had to build these things for myself, and I was all like gung-ho about getting people, using them and making them as easy for users to use as possible. So they all became web applications, even the ones that could have been command line tools, which we definitely want to talk about more.
This.
But first, just to say that there's kind of a pile up, like, where the maintenance of these tools starts to take a significant amount of my free time, where it leaves less time for me to innovate and make the next tool.
Right.
Which I would create in a better way.
Yeah.
Using, newer science. So the fact that there are still people using these older tools, like, maybe they shouldn't be using the old tools, maybe they should move on to the next thing, and at what point should we kill our old software? Like, if we see that there's a competitor that's better, should we just shut it down and be like, stop using this, use this instead?
Yeah.
But what happens when you can't? Because nobody has apparently made a good enough competitor to SplitThreader. For Assemblytics, I think there are. And I've put those up on the GitHub page now. But for SplitThreader, I'm just like, sorry, this is going to be difficult. But you guys can still use the code if you want. I just, can't keep maintaining it on the server. I think a lot of the decisions I made, both software-wise and bioinformatics file formats, like, what are the input files, what are the output files that these tools use? Some of those get outdated, so they don't fit well into people's pipelines, and you get a lot of questions about, like, formatting their data right, and I'm just like, can you please try using something else? But I also don't want to let people down when they really feel like they have no good alternatives.
Yeah, and I wonder if it's also that there might be some alternatives, but they're harder to use.
Yes.
Especially, like, with the web app interface. There's a lot of advantages, but also, as we've come to learn, it can be a lot of disadvantages. Should we dive into that?
Yeah, let's dive into the technical things. I think the user experience thing, a lot of users who use Assemblytics, for instance, tell me that, well, they're not super comfortable on the command line. They don't want to use the other tools because, Assemblytics is so nice. It's a web tool. Like, I just heard from someone teaching a course where they were going to have, many students going through and using Assemblytics at the same time. And I'm like, wow, nice. I hope the server can handle that. It's great that you're doing that, but also maybe you should teach them a tool that isn't 8 years old in a field in which 8 years is a really long time. Because it's analyzing genome assemblies. And now there's, diploid genome assemblies. And Assemblytics doesn't handle anything about diploid genome assemblies. They barely existed. I don't think I remember being on a paper that was, one of the first.
Wow.
Right after, a few years after building Assemblytics, so I was not going to, be able to update that.
And side note, for those of you who want to learn the command line, sandbox.bio is a great solution.
That is the URL. It's not .io, it's sandbox.bio.
.bio.
Yes. Lots of great tools on there. Lots of great tutorials for different command line tools and so on. It's a really good place to learn.
Yes. And so web apps.
Yes. And the technical mistakes we have made and lessons we've learned.
Yeah, I think
both had a lot of notes on this one.
So many notes. The biggest mistake I've made by far was building a web app first instead of building a command line tool first and then wrapping it in a UI that's more usable and that exposes some features that are hard to do on the command line.
Yeah. I have this one too. When I first started, I had no idea that anybody wouldn't want a web app.
Yeah.
I just didn't know enough about bioinformatics, and now that sounds really embarrassing to say. But after a few years, people started asking, someone asked me, hey, can you just make this a command line tool so I can plug it into my pipeline?
Same.
And I was like, oh no. Okay. I have this, should I embarrassingly explain the makeup of Assemblytics?
Yes, please.
Okay. So, mind you, this should be a command line tool.
Mm-hmm.
Okay.
This was 10 years ago, so.
Yeah, 8+ years ago that I made Assemblytics. Okay, so I had the front end also like included PHP, right? So I used PHP to contact the back end of the web app. That then launches a bash script, like by running a bash command within the PHP. And there's also some things about like uploading the user's files to the server and so on. So then the bash script like looks for those files where they should be using a unique ID that's like the entire ID that connects the front end and the back end together, right? So that you know which data to show to that user. So then that bash script includes multiple Python scripts, at least two, at least like 1 or 2 R scripts. And in this case, there was no Perl script, but SplitThreader had a Perl script too.
Very nice.
They're built similarly, so I'm like thinking through it. But SplitThreader had a lot of the same things, but also a Perl script because Mike Schatz had written a script in the past. I adapted that, and I didn't want to have to rewrite it all in Python because this was before, ChatGPT and Copilot, and I would have had to learn Perl in order to understand the script. So I just learned just enough Perl to modify it. Okay, so we have like Python and R, and in the case of SplitThreader, also Perl. And the bash script like checks that the output of each one exists and like outputs a progress log file that the user can see, but the errors get saved in a different file that the user can't see, which was another mistake. Always show all the error messages to the user, because if something is wrong, otherwise they just have to be like, hey, step 2 failed. And like that's all that they see.
Then you get emails.
Yes. I mean, I get emails regardless. I have other software that has much better error messaging, and they just like copy the error message in the email and are just like, hey, look, it says my chromosome is missing. It's like, have you thought about maybe the fact your chromosome might be missing? Do you think that's the problem? So, users will find a way to ask questions about anything.
Yeah.
But in this case, yeah, they have very little information to go on, and I would actually have to go and look up on the server so I can see what the error message is so I can support them, which is worse than them putting the error message directly in the email.
Yeah.
And yeah, as you can hear, it's like a mess of too many different languages, too many like different scripts that in some cases could have been all in one script, but I didn't know how to make plots very well in Python, so I did that in R. Some libraries I wanted to use in R maybe that I didn't have in Python, but I like wrangling data better in Python than in R. And so I was using both because I was still kind of transitioning. Like I was still kind of using both languages for different things at that time in my development as a bioinformatician.
Yeah.
Now I use Python for basically everything. But yeah, that was...
Yeah, that was the second thing on my list was pick your languages and tools wisely. Because I also had Bash, Python, R, and awk.
All hooked in with PHP as well. Yeah.
And it's annoying now because it's hard to maintain, but also it's really hard to install because we didn't even, Dockerize the whole thing. I mean, again, this wasn't that common back then, so...
Yeah,
I think,
we didn't know what we were doing.
Yeah.
There were fewer, there wasn't like a workshop at every conference about how to Dockerize your tools.
Yes, that's true.
Yeah, guidance on how to
on.
document anything. Like I didn't even document which Python and R packages you needed to install because I didn't think anybody would install this.
Yeah.
That was an afterthought. I thought I installed it on the server, I get it up and running, and everybody can just use that from the website. It's beautiful. The whole tool was never meant to be installed by users. That was an add-on I added later when people asked for it.
Yeah, and another problem with web apps instead of CLIs is that web apps just tend to stop working. Like I was researching this. There's a paper in NAR, Nucleic Acids Research. It's called On the Lifetime of Bioinformatics Web Services. It came out in 2020. They looked at 2,400 bioinformatics web tools, And for every single one of them, they were published in the last 10 years. They checked, is the tool still available or not? And so the tools published 2 years after, 90% of them were still up, which I honestly think is surprising.
But 10% of them weren't up after 2 years
Yeah.
of publication. So.
Of publication.
Yeah.
And after 10 years, half of them were down. And now, of course, the limitation of the study, as the authors mentioned, is that this is an upper bound. They couldn't test every single one of the 2,000 tools. They had to rely on the fact that if the page opened, that meant the app still worked. So,
that's very different.
So the numbers are probably more like 25% were probably still up after 10 years.
Based on like your personal expectations.
This is a
of
complete
web apps.
guesstimate.
Yeah, completely making that number up.
But yeah, that's another problem. And I find it fascinating that there are several papers like this that every few years there's a paper that studies how many web apps stay up.
And do you think they find the need to keep studying that?
I don't know, because the numbers kind of stay the same, which is a little sad, because you would think after a while we would have converged on better architecture, but the problem is that typically the people building these web tools are kind of on their own in their lab. They don't have a place to learn that expertise.
Yeah. I mean, I think that makes me think of, in my case, in my lab, there was nobody else who had even made a web application. Nobody, I don't know if Mike Schatz had at one point done it. He was my PhD advisor. But there was nobody else I could possibly rely upon to help maintain this tool, any of the 3 tools I had made, because nobody had the expertise. Nobody knew it as well as I did.
Yeah.
But for me to be the maintainer of it also has issues, because not only is it like a tax on my future innovation that like drags me down, because it like takes so much of my time.
A tax on future. I like that.
Yeah, I mean, it's, there's a cost to having software out there where you have to maintain it.
Yes.
And even if you don't maintain it, then you feel bad.
Yes.
Because you get emails and you're like, oh, I don't know how to help this person. And then you just kind of think about that for a day before you respond to them and try to help them as best you can. But like, you feel bad.
Yeah.
And so it does create kind of a drag, at least on your mood, as like the creator of an open source tool, I think. But, now that 8 years have gone by, sometimes people ask me questions that I have no idea how to answer. Someone, was asking about whether the bed output, which should have been a VCF output of Assemblytics, because it's a variant caller, but I didn't know about VCF files back then because I didn't know anything. So I made it a bed file because I was familiar with those, because, people had told me about bed tools. And so they're like, oh, is it 0 or 1 indexed? Because it's supposed to be, and I don't even remember which one it's supposed to be, because I, don't get that nitpicky in the files usually myself, because I was dealing with this giant variance. So it's like, as soon as it's pretty close, like, I'm good. Like, structural variance, I don't care if it's off by 1. Like, I wouldn't have noticed that myself.
Yeah.
So unfortunately, I have no idea anymore if I wrote it to be 0 or 1, coordinate system, 0 or 1 based coordinate system. I have no idea. And other things I did know at the time, but no longer remember. And when people are asking, like, oh, I got this result with Assemblytics, but I got this result with this other software called Syri, Syri, and I just looked that up. It is like somewhat similar, like it can call variants or something resembling variants from an assembly, but they get different results. That's always such a fun question. I never know how to answer that, even when I mean,
that would take so much time to diagnose. Yeah. Like, are the differences expected, or is something wrong with the tools? Like,
Yeah. And I am not in a position to understand the questions well enough. Like, am I going to go dig into their data to help them figure it out? Like, it's just, it would take a lot of time, but also I don't think that I would be the best person to help them.
Right.
Because I haven't worked with genome assembly for 8 years.
Yeah.
And so if I'm not familiar with this other tool and how it does variant calling, am I supposed to like go and research this tool? Like, you're probably better off figuring it out yourself than asking me for help at this point, unless the server is literally down, in which case I can now help you because recently Cold Spring Harbor's web server, where all our tools were hosted, went down somewhat permanently. And we had to actually scramble to install them ourselves on the cloud, finally. Which I had not done for any other tools than Ribbon, which had already been rescued, which is good because Ribbon is more popular than my other tools. So I'm glad that you had already like give that one a makeover and had it like hosted somewhere else, and
And that's actually, wow, I don't know how this happened. This is the third thing on my list of mistakes or things I would do differently.
I saw your notes, but I don't actually remember what all of them are. So this is
great.
Actually,
We're
coincidental.
really in sync here.
Yes.
Can you run some of the code in the browser? Or at least...
like front end?
Yes.
Okay.
And I think that's one thing
that... maybe define that. A lot of bioinformaticians listening to this will probably not have enough familiarity with web apps to know what we mean.
Right. So in a web app, you have a front end. That's the user interface. That's the code that runs in the browser. And that makes requests to a server that can serve those requests. Mm-hmm. In some cases, like in Ribbon, you can do basically all the analysis in the browser, not have a server, not have to maintain whether the server goes up or down, whether it runs out of disk space, nothing. It's literally serverless analysis.
A big difference that might matter to users in that case is that like when you load your data into Ribbon, because it's basically front end only, your data doesn't go to me on the server anywhere. I don't see your data.
Right. So it's extra privacy.
Right. And it also, like, all the computation happens on your computer as a user. It doesn't go on my computer. Data doesn't go here. There's no scripts that run on the back end.
It doesn't cost you personally.
Right. So it's cheaper to host too. And that's possible in Ribbon because we've like found a way to read BAM files that stays on the front end, that like originally ran in JavaScript and now runs with WebAssembly. We don't need to get into that here because that's a whole like nerd hole that Robert you have. He loves WebAssembly. Go look up BioWasm, WASM, if you want to know more about WebAssembly and like if you work on web applications. Absolutely check that out. If you don't, then don't worry about it.
Sounds good. I will withhold going into a deep dive right here.
Yes. On another episode, we should probably talk about it.
But I think that's one thing I would have done differently is either, for Ginkgo, either do some of the processing in the browser, because that would have been possible. Like we ran BetTools, I think was the first step for some reason. Or at the very least, I would just have the web server do less. Require more upfront processing, because the web app cannot do everything from A to Z anyway. So I think keeping the surface area of what the web app does is important. And the other thing that, being able to do things in the browser also applies to data compression. Like this is something that, looking back at Ginkgo, people upload bed files. And they, I think, almost never gzip them, even though they're extremely compressible. Nowadays JavaScript has APIs for compressing in the front end.
Oh. And
so that can significantly reduce the upload time and the analysis time, because you don't have to do the gzipping on the server and it costs you compute time.
Yeah, or less fancy, just ask users to gzip their files.
That's true, yeah. Just block them from uploading.
They should maybe do that otherwise. Yeah. Or they should do that anyway. But you really made me think of, like, As an example, I think like SplitThreader, that was like my second-ish tool I made, is a great example of where I should have really thought about what do you ask users to do to prep the input data, and what did you call it, like the surface area or something of the web app, like where it actually interacts with the input data. At what stage in the processing does the web app take over? So SplitThreader does visualization for structural variants, large, long-range rearrangements in particular, the kind that you would see a lot more of in cancer, because that's what I was studying, was the cancer genome. So SplitThreader has two different inputs. It has like VCF, that's basic, like VCF or BED-PE variants. And then it has copy number. And for the copy number, I had a pretty long-winded approach where you run a little bash script I have that does some piping in bash and some bed
You do
tools
that
and
locally.
stuff. And the user would have to do that, but they get my script to just like run on their data.
Right.
But it's not very efficient. It's not very well done. But then on the server side for SplitThreader, it would do copy number segmentation. And today I would not have the server do that. I would say the user can bring their copy number data and we're just going to visualize it.
Yes. I think that kind of reminds me of like the thing that successful web apps do is let you do things that are otherwise hard to do. Things like IGV and Jbrows and UCSC Genome Browser and Ribbon. Their core strength is visualizing data, which is really annoying to do on the command line, even if you know how to use it.
Yeah.
And so if reducing the surface area means you're just doing the important part, and then your web app is also probably a lot easier to maintain.
Yeah, I think that's a really good insight. It's like the things that we can make into command line tools, we should just make a command line tool and not actually make a web app. I think these days there are some decent ways to, like, if I had made Assemblytics as a command line tool, now you could plug that into a platform that wraps a nice UI around it and runs it for the people who are not comfortable on the command line.
Yeah.
What's the good example of that? The Terra platform. I think that's a good example. And then you have a bunch of different commercial platforms too, like DNA Nexus, where you can do similar things of like taking a tool and creating kind of like wrap it with a nice user interface for running it.
You know, another example that just came to mind, because this is a collaboration I was involved in, is with the Nema Mashiri Lab at UCSD. So he had, you know, some tools, his own and some other people's tools that he had put together in a pipeline, and it was a command line tool. And that was the first thing he did. And then he wanted an easier interface for people to use it. And that's when he added the web app around it. And that was so much easier to do.
Right. When you've already defined the tool.
Right. And everything it's a lot easier to do it that way.
Yeah. Then you're also not iterating on both the web app and the command line tool simultaneously and being like, oh, let me add this input. Oh, now I have to add it in both places and hook them up. Like every time you do that, it's like extra work, right? If you just build the command line tool once, then you can build the web app once and you're done. Yeah. What other things did we want to talk about?
Well, so one thing I was curious about is like, what are the expectations around how long you're supposed to maintain a web tool or a software tool?
Right.
And so I went digging into a bunch of journals and their guidelines. So the journal Nucleic Acids Research, most people call it NAR. It's a pretty popular one, especially for web tools. Like they have a whole issue every year just for web tools. And so they say any software has to be updated or at least maintained in fully functional form for at least 5 years.
Wow.
Which is on the higher end. The journal Bioinformatics says the software has to be available for at least 2 years. And if it's a web server, it has to be available for at least 3 years. And I think that discrepancy is interesting. I wonder if that's just a typo or it's because they realize that once a web server is down, it's harder to bring back than a command line tool.
I think it's also just expense, because actually having a web tool up and running, right? Like it has to be on a server, and if you can put that on a cloud VM or something, but like you're paying every month for that. And like, what is it to run something like Assemblytics? When I was setting up the server recently, I put it on a pretty small server, but it was still like $7 a month or something. If you're talking like 5 years, like where's that money coming from?
Yeah.
Is that coming out, like this one is coming out of my pocket, but I at least like got the domain names for 10 years back in the past, like because I had funding at the time, so I kind of used that to prepay for at least keeping the domain names up so that I could always route people to the right place.
Yeah.
It's actually another like technical thing that we learned kind of accidentally, because the server at Cold Spring Harbor at one point got hacked, and it was while Assemblytics was like under review.
Oh, wow.
In the journal.
Oh, no.
Yeah. And so because I had luckily bought Assemblytics.com and hooked that up, and that was like the name I put in the paper and everything, or like sent to the journal to say like, okay, this is, where you should say people can go find the software. It didn't use the route that was like QB, like quantitative biology department at Cold Spring Harbor,
Right, so you could move it around.
/Assemblytics,
Yeah.
So then I was able to, like I had control over that domain name. I was able to reroute it to the server that I set up really quickly on Google Cloud VM and just like got it running.
No one noticed the thing.
Yeah. And then like a month or two later, we moved it right back to the server when it was back up and running at Cold Spring Harbor. So that was, really lucky. So the lesson we learned from that is if you are going to have a web app, anticipate that you are not always going to keep that one server under your control, especially as the creator. You might move away and not have access to it anymore if it's run by the IT department at your university, but you're not going to be there in 10 years. Do you still want it to be running? In that case, or even like in 3 years, you might not be there. You might not have access to it anymore. How do you keep it up and running?
Yes,
is your
and
PI going to maintain access? Because in our case, yes, Mike was able to keep access to it for a long time, and then only recently he lost access, and that was when we had to actually, move everything off and pay for it out of pocket on a cloud VM.
Yeah, and I feel like these are the conversations you should have before you release a web tool. Mm-hmm. And I don't think I thought about it 10 years in the future.
No.
I mean, who would have thought people would still be using the same tool 10 years later? Like, why?
I was not looking that far ahead in my own life, let alone in the life of the software I had just made.
Yeah. Gives a new meaning to the question, where do you see yourself in 5 years?
Yeah.
Because this web app is going to depend on you.
You still need to keep it running.
Yeah.
Yes. It's like, I see myself still maintaining Assemblytics. That is where I see myself in 5 years, at the time. Now I don't know.
And so the last journal I'll mention is the Journal of Open Source Software. So I feel like I came across this before, but I don't really know. It stands for JOSS. So they're a journal with a formal peer review process designed to improve the quality of the software submitted. And I thought that was really interesting. Like a whole journal just for software in any science field. And funny enough, they say like many web tools are out of scope. Because of modular...
They're the ones that need you the most.
Right. Because of the lack of modularity and challenges in testing and maintaining the code. Yes, absolutely. Now, web tools may be considered if they are built around a core library that's exposed on the web. So what we said, like start with a CLI and then you run a web tool around it.
Oh, I see.
Or if it demonstrates a high level of rigor with respect to domain modeling and testing, such as using a framework like Django. And I think that's really funny because, they're kind of right. It is fraught with a lot of issues. Yeah. So if you're going to submit there, they're going to require you to show that you're serious about it.
Right. Do you think people are just going to not submit there then? Because it's not like I hadn't heard of it. I don't know if it's more prestigious or anything. I mean, maybe that's what we as a community, as a field, kind of need to be like, oh, that's the good journal. Like, that's the one where, like, your software is going to be really, built really well.
Right.
But, like, does that count if you are not a computer scientist?
Right. That's the problem. Like, if people see that you have a paper written in the journal Bioinformatics, I think that looks different. Like, it looks better.
Yeah. Did you have more on your list of technical lessons we learned? Because I think that was a good conversation. I want to make sure we get all of those.
So the other mistakes I made, not pinning dependencies in any obvious way, not Dockerizing it because it was using so many languages and tools. Not using a web framework. It was glued together with jQuery. In my defense, this was 2015. React was released like a year earlier, so I am not going to blame myself for that. Adding UI tests. This is something like I started...
Any tests.
Or any test.
To be honest.
Or any test whatsoever. Even just unit tests. But there are tools like Playwright where you can now... simulate opening a browser and clicking around and making sure everything still works.
Yeah.
And that's been such a lifesaver. Like working on things like sandbox.bio and 42 base pairs. That's been crucial to make sure that, adding a thing there doesn't make something else that seems unrelated break.
Right.
And the last thing I wrote was sanitize user inputs.
Yes. Because otherwise you get hacked.
Yes.
It was not our fault that the server got hacked, but we have had some issues found in our own code where we didn't sanitize user inputs, and I've had at least one person, file an issue and say, oh, you might want to add some sanitation right here. And then I was like, okay, how do I do that? But I figured it out.
And yeah, it's hard because if you're designing any sort of web tool where there's a backend and that backend executes arbitrary code, because the user needs to give you some inputs in the form of parameters.
Right.
And if they're able to escape out of that bash script and run any command, well, that's...
Right.
Then we end up getting hacked.
Yes. And yeah, that's again something that people who haven't worked with web apps are going to be like, what are you talking about sanitizing user inputs? But yeah, basically it would allow users to get more access to the server than they're supposed to if they can sneak some extra code in with their data in some way.
So one simple example
that's
is
a whole field in itself.
If the UI says enter a parameter number and you say 5, and then on the server it says run this bash script -- parameter, put whatever the user gave you there.
Yeah.
And if they write 4 and then semicolon rm-rf, they can unless you sanitize the user input, they can execute anything.
Right. So you really want to be careful with that. But yeah, I think that's another good one. That's just, another baseline. Definitely should do that. Otherwise, your whole server can get hacked, which is bad. But yeah, I think a lot of the other things you had on that list are super important too. Just keeping the code as simple as possible.
Yeah.
And for web apps specifically, I think the top thing is making the web app itself do as little as possible.
Yes.
Have it just do the visualization or other things that you can't do in a separate script or a separate tool. and then, make users run the separate tool. Actually, a good example I have of that, which is a less known app that I made, is called Dot. It's for making dot plots. And for that one, I had just a Python script called .prep.py, and users would run that on their nukemer output from aligning two assemblies to each other. They would run that. It would output not only like a file, but also an index for that file, so that the front end, there's no back end to Dot at all. It's just front end,
Nice.
Which means I could run it on GitHub Pages, and that's free.
That's amazing.
So that's another like really nice thing. Like if you can make it front end only, that's the perfect web app.
Yeah.
Because that one you can keep up and running for 10 years, no problem.
Yeah, and it means other people can also run it locally really easily.
Yes. You download it and you double click on the index.html file.
Boom.
And it opens in your web browser and you can just use it.
Yeah.
So that's like amazing. And it's just like so much cleaner having that separation of processing of the inputs that you need in order to make the web app work with it versus, what's actually part of the web app itself. So I think if anybody's going to make web apps, try to make them front end only to the biggest extent that you possibly can. Even if that means that users have to do a little more work up front, it's going to be just way cleaner than having any of that done on the server side.
Yeah.
Yeah. Or at least have it as an option. Maybe
Yeah.
have a separate page where it's like, we're going to process this for you. You get the files, and then you load them into the visualization over there.
Oh, I like that.
And that way you can kind of help users out, but if that part goes down, they can still run that part on the command line and load it into what is a completely clean front-end only app.
Yeah, and that makes it
That would
easier
work.
to integrate with other applications too.
Yeah.
That's the other thing about web apps versus CLI.
You can't plug them anywhere.
Yeah.
Yeah. But if they're front-end only, then you can actually plug pieces of them in
Yeah.
to other places, or plug the whole thing into like an iframe or something, even on someone else's website. Like you have a lot more options, and they're way easier to install. And we have learned that, especially like for people working on patient data, they often need to install it locally and have it kind of sandboxed so that it can't contact the intranet and like send patient data anywhere.
Yeah.
And that's really hard to do with some of our applications that, use PHP, Bash, R, Python, etc.
But it works great with Ribbon.
Yeah, amazing. It just works. It's so simple. Yeah, I love what we did with Ribbon and like seeing that evolution over time. And that's also why we're talking so much about the technical details here, because we want people who are making academic software now to really think through some of these things.
Yeah.
Do you think the whole system is working well? Or are there changes that we would propose? Or like how would you define and how would you fix like the current incentive setup?
Ooh. I mean, I think it all revolves around like the fact that as a scientist, you can't become a faculty in biology just based on the software you build.
Mm-hmm.
So you have to you can build software, but you have to use it to discover new biology. And I guess that's fine, but there has to be a place in academia for building and maintaining those tools. Because otherwise they're just built on the backs of other people's careers. Like the people who do stay in academia and do keep maintaining it, they have that tax that you mentioned, and it, if you leave to industry, I feel like it's a little easier to not be as attached,
Right.
perhaps.
Yeah. I mean, you continue to get citations if you keep being in academics. So in some ways, like you get points
Yeah.
because there's a paper associated with your tool.
That's true.
do you think the number of citations, like if you think about a paper that's for, any other biology that isn't a tool, where you've done some experiments and you have some discoveries, versus a paper for a tool, do you think the number of citations are an accurate reflection of how useful or valuable that research is? Like, should we put a multiplier or, a fractional multiplier on tool papers?
Yeah. So I think citations for tool papers are kind of almost irrelevant because, like, foundational tools like samtools, nobody's going to cite those in every single paper if they're not, like, explicitly used to, I don't know, generate a figure or something.
Right.
And so these tools kind of get overlooked because you're like, well, that's a utility. It's not really like a part of my research. And so for the people who do fund software maintenance like CZI, they also look at other metrics like how many people download it and install it every week, and like what does your GitHub look like? Like how much activity is there? How many issues and additional numbers than just the citations, because those can be underwhelming.
Yeah, that's a really good point. Do you think, so for CZI grants, that counts? Do you think it counts for academics at all? I guess we have no way to guess that.
Idea.
We haven't been part of like an academic promotion committee or something. I did a couple of those in undergrad, but I have not for like research.
Well, let us know if you have experience with this.
Let us know in the comments on YouTube.
Yes.
That's the only place you can really comment on this, because all the podcast players don't have that feature. We've been doing this for nearly an hour.
Wow.
That's pretty good, actually. Yeah, I mean, I saw a tweet about this too. Is like, if your paper is cited, it counts, but if you have a bunch of users of your software or a bunch of stars on GitHub, they said like that doesn't count for anything in your career progression. I mean, I think as long as it does result in citations, it's good. But like you said, if you're using samtools or IGV or something and you don't, have to mention them in the paper, then usually you also forget to cite them.
Yeah.
Even though you did use them. And maybe we just need to all get better at that. But I wouldn't even know where to put the citation in a paper if I'm not. So tell us that in the comments too. Where should we put citations in a paper for things that we have used but that we don't need to like state in the paper? Like, these are all the packages we used, 108, 109, 110, 111.
But some journals also have limits on how many citations you can have. So like,
oh, that's bad.
Yeah, it's kind of a hard problem.
Yeah, I had a crazy idea for the question of how could we improve the system incentive-wise.
Ooh.
So I think, first of all, we can talk about, should scientists be paying for software? Should we have, entire teams of people, maintaining the software so that you can... should scientists pay so that you can afford to have a team maintaining the software and doing the support? I don't think that could really work very well because, scientists don't, they need to be able to use tools, and, not every tool has enough users, but can still be important scientifically.
Right.
I notice a lot of the positive examples that we've mentioned of tools that are well maintained are used by a lot of people. Mm-hmm. You don't have to be studying bed files to use bed tools, right? Everyone needs IGV. Almost everyone needs the UCSC genome browser. If you're ever looking at genomic data from, anywhere.
Yeah.
And, all these tools are very, very general. Try to do anything in genomics without samtools. I challenge you. It's very, much impossible. So, but something like SplitThreader, it's, only really useful if you have large structural variants in one genome that you want to look at that cost copy number changes. How often does that happen? Cancer. So it's like, it's very specific. And like, even most people studying cancer are not looking at long-range genomic variants, like long-range structural variants. They're just not. So it's like super niche.
Yeah.
And I would never have enough users to like be able to get grants to maintain it. Like I wouldn't apply it to the CCI grants, for instance, to try to maintain this, also because it's not my dream to be maintaining SplitThreader.
Yeah.
Like I don't want that to be like my focus for the next few years. Like I just don't. I need to continue making new things that appeal to a broader swath of the genomics community. And there's just like a lot of, I think there's a big difference depending on how many users a tool has, what's actually going to work for maintaining it. Right, so that brings me to my crazy idea. So the idea would be that instead of putting the support purely on the creator scientist or on their lab that they are about to leave because they're finishing their PhD right now, or their postdoc, instead of putting that there, and also like the software might be kind of crappy and so on, so I was thinking, let's have a program kind of like Teach for America that trains software engineers by having them refactor and improve academic tools and maintain them.
Oh, I love that.
Yeah, so it's like, you know, it's like a way to train software engineers, more seasoned software engineers like us, I guess, or like your average worker at the big tech companies could have a lot of fun doing this. They can mentor these like trainee software engineers on best practices and like giving them ideas for how they could like, oh, how can you make this web app more lean so it's front end only? How can you like do all this?
Yeah.
And you involve the original scientist creator so that they can also learn how to make the software better in the future, so they don't like keep repeating the same mistakes over and over again. Like they can learn to make better software.
Yeah.
And I mean, in some cases, you could even skip over the training program and just have people like at Google or Microsoft or something like helping,
like rent
scientists.
An engineer.
Yeah, just like mentoring scientists who are building software, so that when you or I are like starting out and we're just like, I don't really know how to do this, we could like have a mentor who knows how to make good software that could just like point us in the right direction. Even that would be an improvement.
Right. Yeah.
And just like, I haven't seen any programs like that, but I feel like both sides would benefit a lot from that.
Yeah. And that would, I mean, the fact that it would be like a volunteer basis would solve the issue that no one wants to fund this.
Right. Yeah. But yeah, like for an actually good analogy is that like for you and I, and we were going to talk about this in this episode actually, like we're starting our own business like officially. So that's exciting. It's called OMGenomics Labs, and we're basically going to continue like we have been doing for years, but now in our business, we're going to be building genomic software that is a joy to use.
Yes.
Right. Like that's
the tagline.
That's the mission. And I think that's like a really important vision. And so as part of that, also in this episode, we've been talking about how can you make genomic software like less painful to use, less painful to maintain. And that's like one step towards joy, right? Like first you have to get rid of the negatives before you can get to the positives. But as part of like starting up our business, we've been like we just talked to a mentor from this government program, SCORE, which is to help small businesses starting up.
Right.
And so we talked to a nice woman who has like 40 years of experience in business, and out of the goodness of her heart, like she volunteers with this program. But the matchup and the whole system is run by the government, right? So like there is some funding there, even if they're not paying her,
right? And
we're not paying for it, but it's like for the good of like starting businesses in the U.S.
Oh, that is very cool. Yeah, that's a good analogy for like a similar program.
Yeah, And yeah, so if you work for the government or something, like if you have the power to start this at the NIH or I'm not looking at you.
Contact
I'm looking
us.
at the audience. Yes. Run it up the chain.
Yeah.
See if somebody can start a program like this. Because I think it could be a really cool way. It's just like a two-sided marketplace. How hard can that be, right? You just need scientists who are building software.
Which there are a lot of.
Yeah. And people, for instance, like software engineers who are experienced and
want to give back to biology.
To give back to science.
I mean,
they all want that.
Yes.
Like having been at Google, I know that a lot of them are like looking for high value volunteer opportunities. And usually there's not a lot that they can do that, is as impactful as helping scientific software to become higher quality.
So let us know if something like this exists or if you can make it happen. Otherwise, we're going to be forced to do it ourselves, and we'd rather not.
Yes. Because we have like a list of 5 other things we need to do first.
Yes.
And we'll give you more updates on all of those types of things in the future.
In future
so
podcasts.
Stay tuned. Yeah.
So what are we...
I think that's a good place to end.
It's a good place to stop.
Yeah, it's nice and hopeful and thinking about the future. Yeah.
Awesome.
So yeah, thank you all, and go leave us comments on YouTube where you can find this episode on the OMGenomics channel. So you can give us feedback, tell us what you think, and stay in touch. Anything else we want to tell people?
That's about it.
That's it. All right. Thank you all.
Bye.
Bye.